I'm Chris Sorrell, AI Advisory Practice Lead here at Catalyte. I'm joined by Jun Wang, our CTO, and Jason Foster, a Principal Architect in our Data Science Group. And today we're going to be talking about the impact of different data types on AI implementation. We're in a new world here where everything is data, and AI can get into everything that we've got. And so we have, of course, security concerns around that. We have concerns about how do we leverage our data most optimally? Do we have the right data? Do we have enough data to answer our questions? So we'll dig into that a little bit, understanding some techniques around how do we approach different types of data? How do we understand if we've got the right data? How do we understand if we're even answering the right questions? Thanks for joining me today. We're going to be talking a little bit about data. Of course, AI is fundamentally a data conversation. You don't have AI without data. And so we want to talk a little bit about how different types of data factor into your AI implementation and the different kinds of concerns we have around that. So I think we've talked quite a bit about data broadly, the types of data and the concerns we have, things like bias. But I want to talk a little bit about data in the sense of how it relates to the business. So when we think maybe first about data and AI, there's this idea of the data that you bring to the table, your data as an organization, and then there's the data that the model was trained on, and those may or may not be the same thing, and that can have some interesting sort of consequences. So Jason, you want to maybe kind of talk a little bit about that?
Yeah, I think one of my favorite quotes is from a Sherlock Holmes story where Sherlock Holmes himself says, data, data, data. I can't make bricks without clay, right? I mean, so you're absolutely right that there's no way that you can do anything in AI without some data. And these days, everything is data. You've got images and documents, PDFs, music even sometimes. Not to mention just all your relational sources, any other kinds of things that are coming in, telemetry that's coming from your website. So there's all kinds of things that are just that are necessary in order to be able to build those things off of. So if you look at what you have, you still have to kind of go back to this notion of what do I want to find out? What questions do I want to answer? How do I want to answer those questions? Do I have the right data to do that? Is it in the right format? Is it in the right place? Those things are all just kind of fundamental to actually doing anything in AI, that is for sure.
And I think maybe to that point, if you consider maybe a bit of an artificial scenario, but if we're doing medical diagnosis, do we really want our model to be trained on data from Reddit, for example? I mean, there's a lot of experts on Reddit, right? And so I think that this is a challenge that we face is ultimately, do we bring our own data? Do we use data that's brought to us? Do we use both? And what's the conflict there? But you also talked a little bit about the different types of data and how they relate and how we have to approach them different. And maybe Jun, you can talk a little bit about what structured data versus content versus how do we have to think about these things as we bring them to the table? Because if everything is data, that's one point, but not every data is in the same structure and can be accessed in the same ways.
Yeah. So I really like the data that I cannot, data as a clay. I think as a fundamental material of modern day technology and generative AI or any kind of machine learning algorithm, data is certainly key. But I want to take a step back to say, because we just said everything is data, I don't want people get sort of concerned I have not been doing data in my organization. I don't have piles and piles of terabytes of petabytes of data, so let's not do AI and wait until. I think because everything is data, there are a variety of different techniques that we can employ to actually make sure that we can turn whatever asset that has been accumulated in any kind of form into actionable sort of AI ready asset. And then the standard ones is if you have any sort of internal databases, relational databases, anything that is a number like financials or internal systems, website tracking systems, reports, documents, And those are like the most traditional data sources that can be easily processed. And then on top of that, then you have text with the large language model. Text effectively become data, and then any of the instructions that you put it out there, any of the documents in PDF formatting, raw text formatting, internal documentation, your HR employment handbook, and all those are technically data. And then one layer above that, when you have images, and one layer above that, when you have audios and videos, depending on the use cases, all of them can be usable. And then one of the things that we should probably pay a little bit more attention to is like what kind of data to solve what kind of problem. So ultimately, depending on what the business problem that we're trying to solve, we can decide what kind of data has become more valuable and what are the processes that we need to design so that we can turn those data into AI-ready assets.
So how do you think we make that determination of like what data is valuable, what's important? If again we have a mountain of data, we have to figure out what's the right stuff. But how do we know what's the right stuff?
Yeah, that's a great question. I think fundamentally, if you know, it depends on, I think, whether you know the problem. You can know the problem that you want to solve, but you may not know what the answer to it is. And so I think in some cases you have to go through some discovery to try to figure that out. It also takes some help, honestly. People that know the kinds of things that you can do with different models and different approaches to solving those problems, to be able to look at your data to see, do you have this? Is this complete? How confident are you in this data? How often does it change? Who's the custodian of it? Is it well documented? All those kinds of things, all that governance that goes along with that. And if you don't know those things, you're not mature in that, and many businesses aren't. It sometimes takes external eyes, and it takes a little guidance to be able to look at what you have and to see if you can actually solve the problem that you're trying to solve or that you want to solve without trying to bring in some other data from some other sources, whether it's purchased or, because there are data sets you may not have thought to collect certain kinds of demographics on your customers. Maybe you can't, but other places can. And so you can get those things and pull them into your system where they're necessary. So I think it's a little bit of both, right? You want to be able to understand what you want to solve, but sometimes it takes some guidance to be able to say, can you actually do that?
Absolutely. I think that's probably one thing that is missing in sort of the older generation technology adoption or even like finding a vendor to provide a certain service. These days, having someone to sort of hold your hand, or at least some sort of discovery, as you were describing, to find out exactly what you have and what problem we're trying to solve, and then what's the connection point, is really key, because it's actually probably more than what a standard organization's capability to say, oh, I know what kind of result AI can bring in, and here's the things that I need to have in order to do that. And typically that's sort of the start of the chicken and egg problem.
So maybe making a really simple analogy here. So if you had a bucket of numbers and your question was, what's 1 + 2? You can probably get the right answer, right? In your bucket of numbers, you can find 3, and so you're able to answer that question. But if your question is, what color is my shirt? You're not going to get the answer out of a bucket of numbers. You need a bucket of words, and so like that concept of, what is the question you're asking? Then backing into, do we actually have the data that's going to answer that? Right?
Yeah, and in some cases, I mean, if you think about outside of generative AI, there are 5 maybe basic data science questions, right? How much or how many? How is this data organized? Is this weird, like anomaly detection? But then there's these other ones like reinforcement learning, where you have to build that data up over time. Like your Roomba doesn't know what your house looks like when you buy it. It has to learn what that looks like, and those self-driving cars are that way. So in that case, you don't have any data. It has to learn it and be able to make decisions, and sometimes bump into things or whatever to make its way around. But those questions that are more deterministic, like how much or how many, you can definitely get those things from your bucket of numbers, so to speak. And even classification, sometimes that's that way too. As long as you've got somebody that can say, yeah, these 5 things go together, that makes this product category, or that makes this kind of customer, that makes this person more likely to churn or whatever, right?
Sure. No, that's excellent. So pivoting a little bit around like the types of data, we were talking about different kinds of data. There's documents, there's videos, there's structured data, there's content. And so I guess maybe I'll ask a bit of a naive question. I have a structured database which represents, let's just say, my transactional system, my financial system, right? So I've got numbers. Can I just point generative AI at that database and get what I want out of it?
We're not too far from it, but no, I think it's generative AI these days. I would like to characterize it as like it's your high school or undergraduate intern. So it has some sort of basic capabilities, but it doesn't really know what you know. You need to teach, and it's the same thing. Like you don't want to like, here's the database, here's the new intern you hired, do whatever you need to do. I think you need to start somewhere. So one way is to sort of have instruction dog has like, here's how you create this and that, and then I think a generative AI can effectively, like in this case, is like it is sort of what's called a natural language to SQL, right? You give me some questions I want to translate into some query language that can work with your database. Another way to approach it is you have piles and piles of SQL or whatever the query thing you did in the past that use as a reference, because or the database schema, because like which table join with which table, or where are the one-to-many, or like all those things are either documented or have been used as best practices from your previous queries. And that's how AI learn, and that's also how like an undergraduate intern learn. Like give them all the history of how we pull this sort of report, and you can then speculate or extrapolate from what you've learned so far.
Excellent. And yeah, I mean, I think that concept of was a light bulb for me around retrieval augmented generation, we call it, where, using generative AI to create the SQL query that you then execute to get the data, using generative AI to format it in a natural language way that's reasonable for users is, that sort of distribution of responsibility, to the places that are best capable of taking that action. So I think that's a really interesting way of looking at it. Another place I've run into interesting challenges is that generative AI or AI probably in general doesn't fundamentally understand analytics, in the sense that it doesn't know what a dimension means, right? It can infer from a schema, we're talking about a time dimension, but it doesn't understand the concept of time. We have to kind of do that stuff. And so when you think about, like, generative AI can't do analytics on the fly. So how do we solve that problem of, we really want to expose analytics data for usage in generative AI, or let's say, chatbots and stuff? How do we approach that problem where we're distributing it to the right systems?
Yeah, so it might be really good at taking like base tables, transactional tables, and being able to construct queries based on relations, as you're kind of mentioning. But if it doesn't necessarily know what kinds of aggregations it's going to get asked for, and so you might have to actually predict some of the analytics that you're going to have to do on the data beforehand to get it into a format that you'll be able to run those kinds of, or have those queries generated against it. Even if it may not have to be just statically stored data. You might just have batch jobs that will go through and just take those things and pull them together, kind of based on the concepts that you have. It may know the sources of those data, and you can pull them into something in memory maybe, and run through those kind of calculations, run through the summaries to get through them. But that's not query based, right? Some of that that's actually code sometimes that you have to write to be able to actually get the data that you're going to need to do those kinds of analytics, and to point that AI at that.
Yeah, and so that concept of preparing your data, right? And so thinking about, again, going back to time dimensions, maybe as an example, you run your analytics, you create essentially a dimension table of your analytics data. Then you can point your system, your generative AI, you can tell it query this table, because now it's just a simple query that it needs to evaluate versus trying to run the entire model. And so I think that, again, that's a place where we delegate to the right systems, right?
Yes. And also to the right people, right? This is another instance where you may need some guidance in how to generate those kinds of things, or how to summarize that data, or how to store it in order to make it a little more accessible to AI. Yeah.
So I'll talk about a special case here. We were talking about it a little earlier. When you get into things like documents, like PDFs, for example, what are some special challenges about that?
I think we're in this transition period where like all of the data that we accumulated over the years are meant to be consumed by human, right? PDF is a great example. I don't even know why we have pages these days. I rarely use printers anymore, so like it should be all, but it was designed from an older generation of technology. So PDF has pages and is designed with tables and charts and text around it for human consumption. Now we're in the process of absorbing data created originally with human consumption in mind for AI. So we have quite a few challenges in terms of like, it's a hybrid of text and image and the numbers and tables and which one is which and how do we concatenate them together so that the AI can absorb it well. Another one is the page breaks, which is a big hassle these days. A table that is long across two tables, we don't really know. You need to go to the first page to find. I think there are a lot of technology that we have to build that you wouldn't consider as AI. It feels like it's just chore. It's like dirty work. But those are the things that's crucial for us to go through this round of AI adoption. That's the fundamental building blocks. It's almost like when we originally transitioned from horse to cars. Like building road is actually the most important piece. It's dirty work, it's cement. It has nothing to do with internal combustion engines, all those fancy things, but that's the crucial piece. I think the building the bridge between transferring data or any kind of asset that is originally created for human consumption for it to be AI consumption ready is the equivalent of building roads in the AI adoption.
Yeah, because in Word documents are the same way. They're may be a little bit easier because it's a standard. You can kind of go through and at least be able to read it. But that is, if you look at the actual code that's behind what that Word document is, like you're saying, two people can look at the same page and say, yep, those things are the same, or yes, it's on this line or whatever. But if you try to infer that from the structure of the PDF or the structure of the Word document, it is dirty work. And it kind of goes to the way that all data is. Like all data wrangling, you have to consider what format it's in, what kind of transformation do I have to do to get it to a point where I can actually consume it with AI, where I can do anything meaningful with it. And that's true across the board, whether it's relational data or PDFs. I think that's still the hardest problem.
So I think we may have hopefully dispelled the myth that you can just sprinkle AI on top of all your data and it's going to solve the problem, right?
Yes.
So clearly there's different cases of types of data and different problems that we're trying to solve, different questions we're trying to answer, and all of that is going to factor into how you implement, what components you use, what technologies you use, what your costs are going to be for that. So I guess, taking it back a level to sort of the business, how does somebody, who's maybe over their IT organization or owns the data but is not maybe a technologist, how do they approach this problem practically to say, I need to adopt AI, I want to adopt AI, I have concerns about PII data or healthcare data or things like that. How do they start to crack that nut? Where would you start?
That's an excellent question. I think the hardest thing really is to kind of pick a starting point. So if you take as truth that the starting point is where the current state of all your data, like maybe the first couple of things are going to be for you to assess your governance, assess your data quality, assess the data sources, assess your infrastructure, how ready is it for that kind of move. So there are some things that have to happen and some analysis that has to happen beforehand. And maybe those are certainly healthy places to start, because you can't just dive in. Like if you're already in a good spot with your infrastructure, you have good governance, you understand that you have the veracity, right, is correct with your data, or it's high, right? If you have those things in place already, then it's down to what questions can I answer with this data, and what questions do I want to answer, and can I answer them with this data, right? That's kind of the second step, and then you can begin to dive in and roll up your sleeves and figure out what you want to do with what you have.
Yeah, an evaluation step. I think this is very different from I want to buy a Gmail service or email service. Or I want to, build some sort of a wire into my house. Like this is a fundamentally rethinking of what you have and what you can solve, and also understanding of what is possible today through technology.
Okay, so a little bit of a recap. Everything is data. and it's a brave new world. We obviously, the most important part is the preparatory part, understanding, again, what data we have, what formats it in, what risks are associated with that data, what bias, is it sufficient to answer the questions, and then we get into the specific processes of how do we prepare that data for AI, and how do we best leverage AI for that data. And then ultimately, I think from that, there's maybe the missing pieces. What do we do when we're in steady state, right? So as we're using our data, we're also generating data. And what do we do with that? Where do we go?
You have to make sure that there's a good feedback loop, because especially if you're training models, the data that you're training it on is going to definitely change over time. You took a snapshot of whatever it was to train your models and to teach them. If that stuff is, you have to assume that it's going to change over time, right? And you have to be able to build that feedback mechanism back in to retrain in some cases. In most cases, I would guess, right, where you have to have that feedback.
Yeah, this is almost the standard definition of machine learning, right? Eventually, the machines should be able to learn from the new data that's accumulated and be able to make adjustments along with the new data and the new algorithm to actually make improvement by itself. That's sort of the eventual goal. And I think we're going to eventually get there once we're on that positive feedback loop.
So assess your data, assess your questions, prepare your data, run it against your AI, feedback to your data, and repeat ad infinitum.